Good evening. In the last lecture, we discussed application of determinants, how to solve linear equations. Then we discussed area of triangle and consistency of equations. Now let me explain. Just listen to me, but please do write the solution after the lecture. Find this is 6th sum from exercise 4.3. Find the area of quadrilateral whose vertices are, actually in textbook, I think they are given in different order, but vertices, rather points in that order do not form a quadrilateral. So they should be in this order only. A minus 3, 1, B minus 2, minus 2, C 3 minus 1, and D 1, 4. So these are the vertices of a quadrilateral. Nowadays, area of this quadrilateral, area of this triangle plus triangle ABC, I mean, plus area of triangle ACD. Actually, it is better to find half into determinant first, because if this value is negative, we have to consider its modulus value. But here both the values are positive. I hope you remember the formula. It is half into which determinant? In the first column, coefficients of x. In the second column, coefficients of y. And third column is 1, 1, 1. So it is nothing but 21 square unit. Sum number 7. Find the value of k if the area of triangle whose vertices are pk0, q22, r43 is 3 by 2 square unit. See, it is area is half value of the determinant. If value of the determinant is negative, then we consider its absolute value. So we do not know whether originally it was 3 by 2 or was it minus 3 by 2. And therefore we say that area is given to be 3 by 2. So half into this determinant is plus 3 by 2 or minus 3 by 2. Simple. Now 2 gets cancelled. Expand the determinant. Value of the determinant is minus k minus 2. It is either 3 or minus 3. Accordingly, k is minus 5 or k is 1. Sum number 8, we'll be doing first and second part. Examine the collinearity of the following set of points. First part, these are the given points A, B, C. Let us find area of the triangle. If area comes out to be non-zero, then triangle is formed, means points are non-collinear. If area of the triangle comes out to be 0, means triangle is not formed. So the conclusion is points are collinear. By the way, how many different methods are there to examine the collinearity of 3 points in general? The simplest method is plot them on graph paper. If we could draw one line through all the 3 points, points are collinear. Then we can use distance formula. If between S is A dash B dash C, then AB plus BC must be equal to AC. Then find slope AB, slope BC. They must be the same. We can use section formula also. This method of determinant. Vector method also. Find out AB bar and BC bar. Find out their cross product. If their cross product is a 0 vector, means points are basically vectors are collinear. So points are collinear. So these are the different methods which can be used. Now do the second part. Now this is the second one. Points PQR are given. Area of triangle comes out to be 15 by 2. Now points form a triangle. So they are non-collinear. Third is for homework. Answer is points are collinear. I think in the last lecture we discussed first 3 properties, but let us revise them. First property, the value of a determinant remains unchanged if its rows and columns are interchanged. From this property, it is clear that whatever is true for row is true for column also. Secondly, we can expand determinant with elements in first column also. In fact, we can use any column or any row elements for the expansion purpose, because we have seen the use of cofactors in evaluation of determinant. Second property, if any two rows or columns of a determinant are interchanged, then the value of the determinant changes, but in sign only. I hope you won't say interchange first row with third column. That is absurd. Now, interchange of first row and third row is denoted by R13. Do not read this as R13. Similarly, C23 denotes interchange of second and third columns. You may also write this as R1, R3 are interchange. C1, C3 are, sorry, C2 and C3 are interchange, like that. Third one is interesting. If any two rows or columns of a determinant are identical, then value of the determinant is 0. In exam, you are asked to prove without expanding that value of the determinant equal to 0. So in that case, you have to show that any two rows or columns are identical. If all the three rows are identical, value is definitely going to be 0. Right? Now, let us discuss property number 4. If all elements of any row or column are multiplied by some number k, then the value of the new determinant is k times the value of the original determinant. Tell me the value of this determinant. Suppose I consider delta as 1, minus 1, 2, 2, 1, 3, 3, minus 1, 1. Tell me the value of this determinant. Value of this determinant is minus 13. Now, multiply all elements, but in third column only by minus 2. First column as it is, second column as it is. When you multiply each element of third column by minus 2, it becomes minus 4, minus 6, minus 2. As per the property, expected value is minus 13 into minus 2. That is plus 26. Let us expand this. Yes, value of the determinant is 26. Now, if we multiply second column of this by minus 2, expected value is 26 into minus 2, that is minus 52. And if we multiply first column by minus 2, then minus 52 into minus 2, that is 104. This means we have multiplied all the three columns, that is all the 9 elements by minus 2. So value of the determinant is minus 2 into minus 2 into minus 2. That is minus 8 times minus 13. Yes, it is 104 only. Right? And that is why I asked that question. Nobody gave the correct answer. Okay, suppose we have got this determinant. After this, I can say take minus 2 common from third column. So that will be what? Minus 2 into which determinant then? 1, 2, 3. Minus 1, 1, minus 3. Third column, when I take minus 2 common, will be 2, 3, 1. Okay. So this is about property number 4. Now property number 5 is simple one. You should verify this afterwards. If each element of any row or column of a determinant is expressed as sum of two terms, then the determinant can be expressed as sum of two determinants. For example, a1 plus x, b1 plus y, c1 plus z, a2, b2, c2, a3, b3, c3. This is nothing but a1, b1, c1, a2, b2, c2, A3, B3, C3 plus X, Y, Z, A2, B2, C2, A3, B3, C3. Okay, so this is the next property. Can I say that instead of A1, I will write X here and A1 here? Is it allowed? Yes, because A1 plus X is the same as X plus A1, right? But observe that second row in all the three determinants is the same. Third row in all the three determinants is the same. In some cases, we come across these two determinants as seen on RHS. So from these two, we can obtain this one. Why can we add these two determinants? Because second row is identical, third row is identical. So just add corresponding elements of first rows. Now why to say corresponding? Otherwise you will add A1 to Z. No, A1 is to be added to X and so on. Okay, so this is property number 5. Now the sixth property is the most important one. Let me tell you the property first. If to the elements in any row, listen to me carefully. If to the elements, now I will not use the word column because there is possibility of confusion. In the beginning only I have told you that whatever is true for row, it is called as transformation. Change is transformation. Whatever is true for row transformation is true for column transformation also. If to the elements in any row are added the same multiples of corresponding elements of any other row or rows, value of the determinant remains the same. For example, if to the elements in any row, say R1, are added what? Same multiples of corresponding elements of any other row or rows, value remains the same. For example, I haven't considered one particular determinant. For any determinant, if I say R1 changes to R1 plus 3R2, this transformation is allowed because value of the determinant does not change. But if I say C3 changes to C1 minus C3, not allowed, value of the determinant will change. Why? Because as per the property, if to the elements in any column are added, now elements to the column C3 are not added. First column C3 is multiplied by -1. So we know that value changes in sign because -1 means change in sign only, right? So this transformation change is not allowed. If I say R2 changes to 3R3 plus 2R2 upon 2, is this transformation valid? Apparently it looks like it is not valid, but it is valid. Why? Because simplify, split numerator, 2R2 upon 2 is R2 plus 3 upon 2 R3. Yes, to the elements in any row are added same multiples of corresponding elements of any other row or rows, value remains the same. Don't worry, we are going to verify this. Suppose I write R3 changes to R3 minus 1 upon 91 R2 plus 417213 R1. Is this transformation valid, allowed? Yes. Value of the determinant will not change. See, value doesn't depend on this factor. Okay. So as per the property, value remains the same. But if you say, now I will use this, R2 changes to R2 plus 11, that is absurd. How can you add 11 to each element? This transformation is not valid. Some students argue, can I say R1 changes to R1 square of individual number? This is absurd. Both these transformations are not valid, allowed. Now let us verify this property by considering particular determinant. Suppose I write R1 changes to R1 minus R2. Can you tell me the row after this change? See, R2, R3 remain as they are. Now, I hope you won't subtract 3 from 1, corresponding element. So, 1 minus 2, that is minus 1. Minus 1, minus 1, that is minus 2. Then 2 minus 3, that is minus 1. 2, 1, 3 as it is. 3 minus 1, 1 as it is. Expected value is minus 13 only. We will make one more change. C1 changes to C1 plus C2 plus C3. Is this transformation valid? Yes. To the elements in any column. So first column are added. Same multiples of corresponding elements of any other column or columns, value remains the same. So C1 changes. Can you tell me what is the new C1? Add all these column elements. So just check this. It is minus 4, 6, 3. Second column as it is. Third column as it is. Expected value of the determinant is minus 13. Let us expand this. So minus 4 into what? 1 plus 3, that is 4. Plus 2 into what? 6 minus 9, that is minus 3. Minus 1 into what? Minus 9. So minus 16 minus 6 plus 9. Yes, it is minus 13 only. I'll again repeat the property. Statement is very interesting and important. If to the elements in any row, if to the elements in any row are added the same multiples of corresponding elements of any other row or rows, value of the determinant remains the same. Value remains the same. Okay. Now main diagonal of a determinant. The main diagonal, that is principal diagonal of determinant A, is the collection of elements Aij where I equal to z. Otherwise you may say this is another diagonal because square has two diagonals. We are interested in this diagonal for which I equal to j. Okay. So it is main diagonal. Now the property says, this is called as triangle property. If all the elements above or below the main diagonal of a determinant are 0, then the value of the determinant is product of diagonal elements, can be verified easily. Just expand this. A1 into what? B2 C3 minus 0 minus B1 into 0 plus C1 into 0. So it is simply A1 B2 C3. Okay. Yes. So we have completed all the properties of a determinant. So we can solve sums now. Exercise 4.2. Without expanding, first question, without expanding, evaluate the following determinants. Actually, wording should be without expanding as far as possible, because if value is not coming 0, at some stage you have to expand. So as far as these three determinants are concerned, value of each is equal to 0. So they should have said without expanding, show that value of each determinant is 0. So D is the given determinant. Now let me explain. I will say by C3 changing to C3 plus C2. Now you may ask me, if this is not asked, can we obtain value by expanding? Yes, you can. See, it's a matter of practice. This is just the first sum on application of properties. So after sufficient practice, you will also be able to use these transformations, changes. So C3 changes, means C1, C2 do not change. Now tell me what will be third column? B plus C plus A, that is A plus B plus C, C plus A plus B, that is A plus B plus C, A plus B plus C. Is that only A plus B plus C? I hope you are getting this. Is this transformation valid? Yes. To the elements in any column, here third column are added same multiples one time corresponding elements of other column. Okay. Now I will say take A plus B plus C common. We have to write this in exam, common from C3. Why? Because each element contains that. So I can write it as factor of determinant. So A plus B plus C. See, this is actually fun, provided you know the properties. So basic work should be done. Now, I hope you understand this. Common means what? You have to divide. So 1, 1, 1. Now, after this, I will say two columns are identical. So directly A plus B plus C into 0 equal to 0. Reason C1 equivalent to C3. As two columns are identical, value of the determinant is nothing but 0. Right. Second, delta is determinant 2, 3, 4, 5, 6, 8, 6x, 9x, 12x. I can say take 3x common from R3. To take 3x common means to divide each element of third row only by what? 3x. So what remains is 2, 3, 4. Note that first and third rows are identical. Value of the determinant is 0. In fact, you may also say, let me explain. Multiply, begin with this. Multiply first row by 3x and at the same time divide determinant by 3x. Why? Because if you just multiply R1 by 3x, value becomes 3x times original value. So either write, let me explain, either write 1 upon 3x into multiply R1 by 3x. So 6x, 9x, 12x, second, third rows as they are. Yes, first and third row are identical. Many students, they say multiply R1 by 3x. But when you say equal to, it is not equal to then because value becomes 3x times. So we write 1 upon 3x. I hope you are getting this. But I can just take 3x common from third row so that first and third, these two rows become identical. Value of the determinant in that case equal to 0. So 3x into 0, that is why it is 0. Now third one, actually it's a matter of practice, but logic is simple. 65, 75, 86 are big numbers corresponding to these as compared to these rather. So why not to subtract multiples of elements in column from third one. So I chose this. C3 changes to C3 minus C to the elements in any column. When I want to change C3, don't say minus C3, 2 C3, 1 by 3 C3 to the elements in third column are added. Now don't say it is subtracted. Subtraction is addition only. So C3 minus 9 C2. Does it help? Yes. 65 less 9 times 7. 63. 65 less 63. 2. 75 less 72. 3. 86 less 91. 1 minute. Just a minute. $81, yeah. 86 less 81. Yes, it is 5 only. I'm sorry. 65 less 63, 2. 75 less 72, 3. 86 less 81, 5. So C1, C3 are identical. Value of the determinant is 0. We will be doing second after third. Third one, using properties of determinant, show that first one, value of the determinant A plus B, A, B, A plus C, C, B, C, B plus C equal to 4ABC. Actually, it is up to you, but you are not expected to expand the determinant in the very first step. Try to obtain at least 2 zeros in any row or any column. So that leaves us with only 1 2 by 2 determinant for expansion. That is why I have used this C1 changes to C1 minus C2 minus C3. See, I'm not saying this is the only method. In fact, you may go for R1 changes to R1 minus R2 minus R3. See, A plus B less A less B, you get 0 here. But then A minus C minus C. So you get minus 2C here. Here also minus 2C, right? But I have used this transformation. Now minus 2C can be taken common. You can choose to expand at this stage also, but as I said, we'll try to get 2 zeros in any one row or column. Can be obtained easily. How? R2 minus R3 or R3 minus R2. See, there are many possibilities, but you have to be very careful. Don't say R3 changes to R2 minus R3. No. When you say R3 changes to, in R3 something should be added. Something means don't say 11, 10, 15 like that. I mean multiples of corresponding elements of any other row or rows. Can you say R3 changes to R3 plus R3? No, that becomes R3 changes to twice R3. You are multiplying third row by 2. So value will be 2 times the original. So that is not allowed. Okay. So this is allowed. Now just expand. So minus 2C into 0 into. In fact, 0 into, that is why I have directly written. In fact, I haven't written 0 also. Then minus A into, omit this row, this column. So B minus 0 plus B into minus A. So minus 2C into minus 2AB, which is nothing but 4AC. So we stop here. You try second one, use of, I'll give one hint. Change the base. That's it. If you change the base, then it is just 2-step solution.